Hi everyone, it's Mrs. Bothers, and in this video we're going to talk about greatest common factor, or GCF for short. Now first, it's important to understand what a factor is. And a factor is a number that divides evenly into another number without a remainder. So for instance, if I ask for factors of 10, those would be 1, 2, 5, and 10, because each of those numbers divides into 10 evenly without a remainder. Now the greatest common factor, and basically if you listen to the name, it tells you what it is. It's the greatest factor that two or more numbers have in common. So here are our notes on GCF, and what I would like you to do is go ahead and pause the video and copy this down in your MSG. Once you're done copying, go ahead and unpause the video, and I'm going to explain what all of this means. So as I said, there's two ways to find the GCF. The first method is by making a list of all of the factors. To do that, you would list all the factors of the given numbers, and then find the greatest factor that they have in common. So for instance, if I wanted to find the greatest common factor of 28 and 42, by making a list, what I would do is list all of my factors of 28 and all of my factors of 42. And this is where those divisibility rules will come in handy, because it's not always super easy to see if a number is divisible by another number. So keep that in mind. The divisibility rules will help with this. Alright, and I noticed when I look at both of these lists, there are several factors that they have in common. They both have 1 in common, they have 2 in common, they have 7, and they have 14. Well, we're looking for the greatest common factor, and the greatest one they have in common is 14. So that's basically how you would use the list method. List all the factors and find the greatest one that appears on both of those lists. The second method, the sled, it's also called the ladder sometimes, but this method is actually, it tends to be a little bit easier. So I'm going to walk you through this, this method. Now notice I gave the exact same example. We're using 28 and 42 just like we did in the list, and I did that so that you could compare the two methods and see which one you think might be easier. Alright, so I'm going to redo this even though you've already got it written down. So I'm finding the GCF of 28 and 42. So my first step is to write the numbers on a sled. So I would write 28 and 42, and that's my little sled right there. Notice it says it's like an upside down division sign. Like if you were to flip that upside down, it's basically like a division sign. Alright, and so then your second step is to divide out a common factor. Well, a common factor of 28 and 42, and again, your divisibility rules will help here. I know that they're both divisible by 2 because they're both even. I know that they're both divisible by 7. So I could use either one of those. Since I used 7 on the example we wrote down, I'm going to use 2 here just to show you it doesn't actually matter which factor you divide out with first. You'll still get the same answer. So I know they're both divisible by 2, so I'm going to divide out the 2. And like I said, it's like an upside down division sign, so I'm going to treat it like a division sign. If I divide 28 by 2, I get 14. And if I divide 42 by 2, I'm going to get 21. Okay? Now, number 3 says to continue until the only common factor is 1. So I'm going to go ahead and put these on a sled because they have another common factor besides 1. So I'm going to write them on a sled. And a common factor they have is 7. So I'm going to divide out 7. 7 goes into 14 2 times, and 7 goes into 21 3 times. Now when I look at these two numbers, 2 and 3, the only common factor they share is 1. So I can't go any further, because if I divide out 1, I could sit there and do that all day long. It's not going to change what I have here. So once my only common factor is 1, I'm going to multiply all the factors that I have on the left. So on the left of the sled here, I had 2 and 7. 2 times 7 is 14. So that is my GCF of 28 and 42. And again, if you notice here, I got the same answer when I started by dividing out by 7 instead of by 2. So it doesn't matter which common factor you start with. So let's take a look at another example here. We're going to find the GCF of 48 and 36. And we're going to use both of those methods that we learned to figure out this problem. So first, let's start with the list method. So with the list method, I need to list all the factors of 48 and all the factors of 36. Alright, so when I list the factors of any number, I always start with 1 because 1 is a factor of everything. So I'm going to begin with 1 and 48, and I'm going to leave myself a lot of space here to fill in the other factors. Alright, I also know 48 is even, so it's divisible by 2. 2 would go into 48 24 times, so 24 is another factor. Then 3 is a factor, and I know that based on my divisibility rules. Now you may not know how many times 3 goes into 48, so you would need to actually divide that out. And 48 divided by 3 would give us 16. I also know 4 is a factor, and that's 4 times 12. 5 is not a factor, 6 is a factor, and that's going to be 6 times 8. 7 is not a factor, so I know I've got all of my factors of 48. Now let's go with 36. Okay, so I've listed all the factors of 36. Now the greatest factor that they both have in common, if I look at both these lists carefully, I see they both have 12. Now, it's true they both have 6 in common, 4, 3, 2, 1, but the greatest common factor is 12. Now we're going to look at how easy it is to use the SLED method on these same exact numbers. So if I use the SLED method to find the GCF of 48 and 36, I'm going to write both of those numbers, put them on the SLED, which again is like an upside down division sign. Alright, think of a number that can go into 48 and 36. And it does not matter which number you start with. I know that they're both divisible by 2 because they're even. I know they're divisible by 6. I'm just going to use 6 and then divide it. So 6 goes into 48 8 times. 6 goes into 36 6 times. Now look at these two numbers here. I know they both share a common factor of 2, so I'm going to draw another SLED. Divide out the number 2. And then 2 goes into 8 4 times, and 2 goes into 6 3 times. 4 and 3 only have a common factor of 1, so I'm going to stop here. For my GCF, I multiply everything on the left of the SLED, so that's 6 times 2, which is 12. And as you can see, that's actually a lot less work, and it usually goes quicker than trying to list everything out. Now you might be wondering, could you start off with 12? Because you may have noticed right off the bat that 12 is a factor of 48 and 36. And let's see if that works. If you notice right off the bat that 12 is a factor, divide out the 12. 12 goes into 48 4 times, and 12 goes into 36 3 times. These don't have any common factors, so I'm going to stop there. And I only have one value on the left, so that is my answer. So my GCF of 48 and 36 is 12. So let's take a look at 2 more examples. And I'm going to focus on the SLED method here. So we're going to start with 21 and 63. So I'm going to write both of those numbers on a SLED. And can you think of a factor that goes into 21 and 63? And by the way, your multiplication chart can help you with this. Find a row or a column that has both 21 and 63, and that will help you figure out their common factors. Now I know they're both divisible by, let's say 7. So I'm going to divide out 7. And divide. 7 goes into 21 3 times, and 7 goes into 63 9 times. I'm not going to stop here, okay? 3 and 9 both have a common factor of 3, so I'm going to draw a SLED here, divide out that common factor. 3 goes into 3 1 time, 3 goes into 9 3 times. I can't go any further because 1 and 3 only have a common factor of 1, so I stop here. And for my GCF, I take the numbers on the left. 7 times 3 is 21. So my greatest common factor of 21 and 63 is 21. Alright, let's try another one. And that's 72 and 96. Now I can tell you right here, if you use the list method for this, you're going to be listing factors all day long. Because 72 and 96 both have a ton of factors. So let's take a look at the SLED. And I know they're both divisible by 2 because they're even. But I would recommend trying to figure out start with the largest number you can come up with, because you'll get to your answer a little bit quicker. Alright, so I'm going to just go ahead and start with 2. And you may not know off the top of your head how many times 2 goes into 72, so you would need to divide that. And when I divide 2 into 96, I get 48. Now I know that 36 and 48 have a common factor of 12, so I'm going to divide out 12. 12 goes into 36 3 times, and 12 goes into 48 4 times. I can't go any further because 3 and 4 only have a common factor of 1. So I stop here. I'm going to take what's on the left and multiply. So 2 times 12 is 24. So that tells me my greatest common factor of 72 and 96 is. Alright guys, so I hope you find this helpful. Bye-bye.